Hi everyone, welcome to day 13 of home instruction. This is our second online video. Hope everybody is staying safe and healthy at home. Today we are going to focus on multiplying and dividing numbers written in scientific notation. So first we're going to think about multiplying regular exponents like we did earlier this month. When you're multiplying with exponents, you keep the base. Zoom this in a little bit. There we go. Make this a little neater. You're going to keep the base. And the base, remember, is the number that is attached to the exponent. And we're going to add those exponents. Again, we did this back in earlier in March. So like just a little reminder for us. Maybe this will help us out. Draw a little bubble here to show you what I'm talking about. When you have something like x squared times x to the third, you keep the base is the x attached, and you add 3 and 2 to get 5. So a little bit of a reminder of what I mean by that. So when we're multiplying numbers written in scientific notation, what you want to do is multiply the numbers in the front. So the numbers in front of the multiplication sign is what I mean by that. So in this case, 2 and 4. This example, we rearranged it to show the 2 and the 4 being multiplied. You don't actually have to rearrange it unless that's something you are comfortable with. So we multiply those numbers in the front. We're going to keep that multiplication sign in the middle. And then what we're going to do is, just like I showed you up here, keep the base, add the exponents. You're going to keep that base of 10. So you're multiplying 10 to the third times 10 to the fourth. You're going to keep that base of 10. And you're going to add the exponents. So 3 plus 4 is 7. So we have 2 times 4, which gives us 8.0, times 10 to the 7th power. So let's try some examples together. This one here. So we have, and make sure our final answer is in scientific notation. I'll show you what I mean by that, because luckily for this example here, the top example, we ended up with the number in the front being 8.0. So that's between 1 and 9.9. In some cases, you're going to find that when you multiply, you're going to get, multiply or divide, you're going to get a number that doesn't fall in that range. So you're going to have to take an additional step. We will see that very soon. Okay, so in this first example, we're multiplying 4 times 10 to the fourth by 2.2 times 10 to the third. So what we want to do first is multiply those numbers in the front. 4 times 2.2. That gets us 8.8. We're going to keep that multiplication sign in the middle. And now we're going to worry about the 10 to the fourth and the 10 to the third. So again, just like regular exponents, we're going to keep that 10 the same when we're multiplying them, and we're going to add those exponents. So 4 times 3 is 7. Since this number in the front here is between 1 and 9.9, then we're good. We're in proper scientific notation, and that could be our answer. In the second example, we're going to do the same thing. We're going to multiply those numbers in the front. So we're multiplying 1.4 and 7.6, which is going to get us 10.64. We're going to keep the multiplication sign, and then we're going to keep the base of the 10 when we're multiplying them and add the exponents. So we end up with that number. But think to yourself, why is this not our final answer? Well, this number in the front here is not in proper scientific notation. That number needs to be between 1 and 9.9, and it's bigger than that. So what we want to do here, I teach this differently than your regular math teacher, so if they do something you like better, absolutely use that. This is my trick. You do not have to use this, but you do have to get the same answer as me. So whatever method you get to get there, doesn't matter to me. Just make sure you get there. So this is my little trick. To get this number, this 10.64, between 1 and 9.9, you have two options. You're going to have cases where you need to multiply by 10 and divide by 10. Multiplying by 10 makes your number bigger. Dividing by 10 makes our number smaller. In this case, we want to make this 10.64 smaller. So dividing makes our number smaller, so we're going to want to divide this by 10. I'm going to draw this little wave here. And what this wave represents is if we divide by 10 on this side of the wave, we have to do the opposite. The opposite of dividing by 10 is multiplying by 10. So now, let's see what we get. 10.64 divided by 10. All we do there, you can use your calculator or just know in your head that that's going to get you 1.064. I'm actually going to move that over a little bit so we have room. 1.064 times 10. Now, let's fix the other side. So it's 10 to the 10th times 10. Now let's think to ourselves, when there's no exponent, there's a secret exponent of 1, right? So just like multiplying exponents like we did up here, we're going to add them. 10, we're going to keep that base of 10 and add. 10 plus 1 is 11. So our final answer written in proper scientific notation is 1.064 times 10 to the 11th. Again, you don't have to use my method. If your general math teacher's method works better, absolutely use it. Just another idea if you're having a tricky time with it. Let's move on to dividing. Very, very similar ideas. Let's change this pen color first. Let's try green. Try something new. Okay, when you're dividing, you want to keep that base of 10, just kind of referring back to what we did earlier in March. And when you're dividing exponents, you're actually going to subtract them. So this example here, what we're going to do is those numbers in the front, we are going to divide them. So in this case, 9.6 divided by 1.6, or 9.60 divided by 1.60, we're just going to divide those numbers. That gets us 6. We're going to keep that multiplication sign in the middle. And then when we're dividing exponents, what you're going to want to do is you're going to want to subtract them, as we said above. So 7 minus 4 is 3. So our final answer is 6 times 10 to the 3rd. Let's try some of these examples together. 4.8 times 10 to the 5th divided by 1.2 times 10 squared. First, you're going to want to divide those numbers in the front. So you can use your calculator for this. 4.8 divided by 1.2, that's 4.0, or just 4. You're going to keep that multiplication sign in the middle. When we're dividing exponents, we're going to keep the base and subtract them. 5 minus 2 is 3. And this number is in proper scientific notation because this 4 is between 1 and 9.9. This next one, we're going to do that same thing. We are going to divide the numbers in the front. 1.0 divided by 4.0. If you use your calculator, that will get you 0.25. Keep that multiplication sign times 10. We're going to subtract those exponents. 3 minus 7 is negative 4. Make sure you have the negative there. Do not forget your exponent rules. So this answer here is not in proper scientific notation. This 0.25, it's smaller than 1. We need that number to be between 1 and 9.9. So again, our two options here is we can either multiply by 10 or divide by 10. Multiplying by 10 makes our number bigger. Dividing by 10 makes our number smaller. We're looking to make that number bigger. So we want to multiply by 10. We draw ourselves a wave the opposite way this time because we're not dividing. If the wave is on top, we multiply. If the wave is on the bottom, we're going to divide. So if we multiply on this side, we're going to want to divide by 10 on this side. So let's do our math. 10 times 0.25, that just multiplies. You can either use your calculator, or you can know that if you multiply by 10, that just moves the decimals to the right ones. Keep that multiplication sign times. When our base does not have an exponent, it has a secret exponent of 1. So we keep that 10 when we're dividing. Then we subtract those exponents. -4 minus 1 is -5. And that is our final answer. All right, that is all for today. If you have any questions, please reach out and have a lovely, safe day. And come back to my website for stuff to do for day 15, 2 days from now. Bye.